In this video, we'll take a look at the inverses of the trig functions. So remember that an inverse is when you take the x and the y and switch places. So for example, inverses, if y is equal to 2 to the power of x, remember that the inverse x equals 2 to the y, and rewrite y is equal to log base 2 of x. So exponentials and logarithms are inverses that we've talked about before. So we can also have inverses of trigonometric functions. So if we have the function y is equal to the sine of x, remember that x is equal to the degree measure, or to the angle measure. Could be degrees, it could be radians. So x is your angle measure, and y is equal to the sine of your angle. So looking at the sine function that we've done before, the domain, negative infinity to infinity, we can put any value that we want to in for the domain, and the range are all the values between -1 and 1. So when we find an inverse, your function has to be 1 to 1. That means it's a function because it passes the vertical line test, but it also has to pass the horizontal line test. The sine function does not pass the horizontal line test for the entire domain. So we take a look around angle measure of 0 and restrict the domain of our sine function so that it is 1 to 1. So if we look at the sine function only from negative pi over 2 to pi over 2, that section only, restrict the domain, that has an inverse. So the inverse function, if we take the inverse, y is equal to the inverse sine of x, that's the notation. That means now that your x values are the sines of the angle, and your y values are now the angles. So we've switched x's and y's. And in this case, the domain is now the range of the original function. So the domain are the values from -1 to 1. And the range is the restricted domain from the graph above from negative pi over 2 to pi over 2. So the graph of the inverse sine of x, you can only use the angles negative pi over 2 to pi over 2 as values. So we can't use every angle, we can only use these particular angles. So that's the graph of the inverse sine. And we look at a very similar process with the cosine, except now when we start with the cosine, we're using only the part of the cosine. We're restricting the domain from 0 to pi, so that when we have a 1 to 1 function and take the inverse, our inverse cosine function will have a domain of -1 to 1, and this time the range is 0 to pi, because we had to restrict the domain on the original cosine function from 0 to pi to make sure it's 1 to 1. So when we're looking at inverse functions, inverse cosine, x is the cosine and y is the angle. So how does this work? Let's take a look at some of the values from our unit circle. If we want to find the exact value of the inverse sine of square root of 3 over 2, that means what angle between, and we have to use the restricted domain, what angle between negative pi over 2 and pi over 2 has a sine of square root of 3 over 2. So we take a look at our unit circle, and we can only restrict the values between negative pi over 2 and pi over 2. So when you take a look at the unit circle, pi over 2 rotating positive, and then pi over 2 rotating negative has a coterminal angle of 3 pi over 2. So in this values on just the right-hand half, what has a sine of square root of 3 over 2? Remember that square root of 3 over 2 is the y-coordinate. So at pi over 3, the y-coordinate is the square root of 3 over 2. So the sine, inverse sine of square root of 3 over 2 is equal to pi over 3. All right, second, let's take a look. Find the exact value of the inverse sine of negative square root of 2 over 2. So that means what angle between negative pi over 2 and pi over 2 has a sine of negative square root of 2 over 2. So let's look at our unit circle. So between pi over 2 and negative pi over 2, only the right-hand side of the unit circle, the y value of negative square root of 2 over 2 corresponds to 7 pi over 4. But that's not in our domain, so we have to express it as a coterminal angle between positive and negative pi over 2. So think about it as rotating in the negative direction. So we're rotating negative pi over 4. So that exact value of the inverse sine of negative square root of 2 over 2 is equal to negative pi over 4. And again, that's coterminal with 7 pi over 4, but we have to write our angle in terms of the limited range that we have. All right, last example, find the exact value of the inverse cosine of negative 1/2. That means what angle between, our angle has to be between 0 and pi, because that's the limited range of the cosine function. So find an angle that has a cosine of negative 1/2 between 0 and pi. So take a look at the unit circle. We can only look at the values between 0 and pi, the top half of the circle. And we're looking at inverse negative 1/2, so that means the x value has to be negative 1/2. So an x value of negative 1/2 is here, so that's at 2 pi over 3. So the inverse cosine of negative 1/2 is 2 pi over 3. So remember that on the unit circle, as you're looking around the unit circle, for each sine, exact value of sine, cosine, there are two values around the unit circle that have those measures, the angles. So you have to express them in terms of your limited range. All right, so let's take a look at the inverse tangent function. The inverse tangent function takes just one period of the original tangent function. So if y is equal to the tangent, we take a look at the first period between negative pi over 2 and pi over 2. We limit the domain and take the inverse. Our domain of the tangent function, we're only going to limit it to between negative pi over 2 and pi over 2, and the range is all real numbers. So now when we take a look at the inverse, the range and domain switch places. Now the domain is negative infinity to infinity, but the range is negative pi over 2 to pi over 2. So that's the same as the sine. So when you're finding an exact value of the inverse tangent of negative 1, you want to know what angle between negative pi over 2 and pi over 2 has a tangent of negative 1. So when we look at our unit circle, tangent is sine divided by cosine. So that means when the sine and the cosine are the same, square root of 2 over 2, negative square root of 2 over 2, then this is the place where the tangent of the angle would equal negative 1. So the inverse tangent is 7 pi over 4, but we need to express it between pi over 2 and negative pi over 2, so that would be rotating negative pi over 4. So the inverse tangent of negative 1 is equal to negative pi over 4. All right, so those are the inverse trig functions. Now, if you can't find exact values and we need to use a calculator to find the value, then these we go ahead and just type in the calculator, and the calculator takes care of the proper domain and range. So I'm going to go ahead and just use Desmos, or you can use your scientific calculator or your TI calculator. And if it doesn't say whether they want the degree measure or the radian measure, so I'll do both. For the most part in calculus, you'll be working with radians. So my calculator is in degrees. I want the inverse cosine of a third. In Desmos, sine, cosine, and tangent are here. On a graphic or a scientific calculator, you usually have to hit second and then sine. In Desmos, they're underneath functions. So if I want inverse cosine of 1/3, 1 divided by 3, then in degrees, it's about 70.53 degrees. If my calculator is in radians, it'll give me the radian measure that has a cosine of a third. So if you're using Desmos, click changes it to radians instead, and it's about 1.23 radians. So same inverse tangent. If you want degree measure or radian measure, the inverse tangent is in functions, or it's usually the second, and then hit tangent, negative 35.85. So if I'm in radians, I get a negative 1.54. Or if I want degree measure, make sure your calculator is in degrees, and that's about negative 88.4 degrees. Notice they're giving the inverse cosine and inverse tangent in degrees and radians in the domain, in the correct domain, either from 0 to pi for cosine or from negative pi over 2 to pi over 2 for the tangent. All right, so where do we use this? We use this in right triangles, and you have used this in right triangles. So if we want to find in this right triangle an angle, and we're given the hypotenuse, and we're given the adjacent side, then the trig function that uses adjacent and hypotenuse is cosine. So the cosine of my angle is equal to 9 over 12. So that means that the angle is equal to the inverse cosine of 9 over 12. Or you can reduce your fraction. It doesn't matter. On this case, the inverse cosine of 9 over 12 is what's going to give me the angle measure. Since it's a triangle, a right triangle, I'm going to have my calculator in degree mode. So I want to make sure I'm in degrees. I want the inverse cosine of 9/12, or the reduced fraction. Either way is okay. And I get about 41.4 degrees. All right, so the next part we're going to take a look at is compositions of inverses. Remember, compositions of functions, we take and combine two functions. So the properties, a sine function and its inverse, if you take the sine of the inverse sine of x, it equals x. And your x, for every x in the interval, negative 1 to 1. The inverse sine of the sine is also equal to x, but your interval has to be between negative pi over 2 and pi over 2. For cosine, cosine of the inverse cosine of x is x for every x in the interval. But if you're taking inverse cosine of the cosine, it has to only be in the interval 0 to pi. And same for tangent. So it makes a difference if you're taking the tangent of the inverse tangent, or if you're starting with inverse tangent composed with tangent. So how does this work? So let's take a look. If we're finding the cosine of the inverse cosine of 0.6, so find cosine up here. Cosine of the inverse cosine of any value is itself. For every interval, negative 1 to 1. The 0.6 is in the interval, so this is going to equal 0.6. If we take the inverse sine of the sine of 3 pi over 2, okay, then the inverse sine of the sine of x is equal to x for every x in the interval, negative pi over 2 to pi over 2. 3 pi over 2 is not in that interval. So what angle measure is in that interval that we can express the same as 3 pi over 2? So if you take a look at your unit circle where 3 pi over 2 is, 3 pi over 2 can also be expressed as a negative rotation, negative pi over 2. So we express that 3 pi over 2 as negative pi over 2. So the inverse sine of the sine of 3 pi over 2 is negative pi over 2. Then cosine of the inverse cosine of 1.5 would equal 1.5, except cosine of the inverse cosine for every x in the interval negative 1 to 1. 1.5 is above that interval. It's not in the correct range domain. You have to have between negative 1 and 1. So this does not exist. All right, so those are compositions of functions with itself, cosines with cosines and inverse cosines, sines with inverse sines with sines. What if you're taking a composition of two different functions? Find the exact value of the cosine of the inverse sine of negative 1/2. So we work from the inside of the function out. So first thing we do is find the inverse sine of negative 1/2, and then we find the cosine of that value. So the inverse sine of negative 1/2, take a look on your unit circle. And again, our domain is limited between pi over 2 and negative pi over 2. So we have 1/2 as the y value. Pi over 6 has a sign equal to 1/2. And then 11 pi over 6 has a sign equal to negative 1/2. So think of that as rotating negative. So the inverse sine of negative 1/2 is negative pi over 3. So the inverse sine, let me write it down this way. Find the inverse sine of negative 1/2 is equal to negative pi over 3, because it has to be between negative pi over 2 and pi over 2. Then take the cosine of negative pi over 3. So negative pi over 6. Sorry about that. Let me go back and correct that. That's pi over 6. So we want the cosine of negative pi over 6. And the cosine of negative pi over 6 is square root of 3 over 2. So work from the inside out. Find the inverse sine of negative 1/2, what angle measure that is, then find the cosine of that angle. So what if you find the exact value of the sine of the inverse tangent of 3/4? Well, exact value means we can't use a calculator, and 3/4 is not a value of tangent that we have on our unit circle. So to find the inverse tangent of 3/4, remember that the tangent of some angle is equal to 3/4. So what we do is we can use a sketch of a right triangle to figure out the acute angle. Here's our angle theta. Tangent is opposite over adjacent, so the opposite would be 3, adjacent would be 4. Then find the hypotenuse of your triangle if you know 3 and 4. So we take 3 squared plus 4 squared is equal to the hypotenuse squared. And we get 9 plus 16, 25. So the hypotenuse is going to have a measure of 5. So in our triangle 3, 4, 5, what is the sine of the angle? The sine is going to be opposite over hypotenuse, so the sine will end up being 3/5. Okay, so we're finding the sine of whatever that angle is. So we're using right triangle trigonometry in the composition. So last example, evaluate the tangent of the inverse cosine of 10 over 13. So this tells us that we have an angle whose cosine is equal to 10 over 13. Cosine, remember, is adjacent over hypotenuse. So draw your triangle, label your angle, and then the adjacent side would be 10, hypotenuse is 13. So we want to find this side length. We'll call it x. So we have in our triangle that x squared plus 10 squared is equal to 13 squared. So x squared plus 100, 13 squared is 169. Subtract 100 from both sides, we get x squared is equal to 69. Take the square root of both sides. X is equal to the square root of 69. So what is that? That's 3 times 23. That can't be simplified. So this side length is the square root of 69. Now we want to find the tangent. So whatever that angle is, find the tangent of that angle. Tangent is opposite over adjacent. So the opposite side would be the square root of 69 over the adjacent side, which is 10. So the tangent of the inverse cosine is equal to the square root of 69 over 10. So again, inverse cosine 10/13, it tells us the not the angle measure, it's an angle who has a cosine of 10 over 13. So draw your right triangle, find the missing side, and then find the tangent of that angle.